Dear competitors and guests, welcome to the 8th annual BubbleCup and the 1st annual inaugural BubbleCup Conference. Firstly, give yourselves a big round of applause for making it to the finals. I hope you had a good journey to Belgrade, and I hope that you'll feel even better as you'll be as even happier when you leave after having a really good time and success at the BubbleCup and in Belgrade. Over the next few hours, we'll do our best to keep you awake after your lunch and on a nice warm day. But we have some great speakers here that will share their words of wisdom with you. Before we get started, I was told I have to mention something several times, but bear with me. It's administrative and boring, but important. So you will have received or will receive T-shirts. Make sure you wear the T-shirts to the competition on Saturday. It's either with T-shirts or nothing, so have your T-shirts. Another thing is, there will be in your packs, there will be bracelets. The bracelets are your basically tickets for the party on Saturday. And given this event is combined with the festivities for the celebration of 10th year anniversary of Microsoft Development Center Serbia, it's going to be a great party, so you don't want to miss it. Make sure you have your bracelets. So, our first speaker today is a lecturer at... Can we have the slides? One second. Yes. So our first speaker today is a lecturer at Comenius University in Slovakia. He is a past gold medalist at International Olympiad in Informatics and ACM ICPC. He has over 15 years of experience organizing programming contests, most notably including the International Olympiad in Informatics. From Poprad, Slovakia, living in Bratislava, please welcome Michal Forisek.
There we go. Hello. Okay, hello everybody. I'm pleased to be here. Congratulations on making it to the finals. Good luck tomorrow. And now for the next 20 or so minutes, I'm going to entertain you with some random ideas. All right. Okay, 1, 2, 3, 4. Oh. Okay. All right. This is better. Okay, can you hear me in the back? Can you hear me? Okay. So let's start. Okay. So a little bit about me. Here's a very distorted, funny picture that looks better on the screen than it looks on the beamer of me crossing some gorge. I am very enthusiastic about programming competitions, did many of them as a contestant, did many of them as an organizer, but I also try to have a normal life. One of my interests is badminton, another is hiking. I actually climbed a mountain that was over 5,000 meters of altitude. And I'm going to talk about programming contests today. Can I remove this? Let's try. One. Oh, okay, this is much better. Sorry about that. Technology seems not to like us. There's something wrong in the resolution, so just listen to me more and read less. Alright, so the programming contests have certainly changed since the age when I was first competing. My actual IOI competitions were done under MS-DOS, and we were submitting solutions by storing them on floppy disks, and then those floppy disks were manually one after another entered into a machine during the grading, and the grading was a process that took until like 4 a.m. on some days. But even though the implementation of these procedures changed, the main idea of these programming competitions didn't. It's still the same thing. It's still a bunch of geeks who get together, have fun, and challenge each other to do better and to be better problem solvers. And some of the questions I received before this talk were questions about how to train and how to become a better programmer. especially in competitions. And if you see, like in the news, a report from some programming contest, usually if you are brave enough to open the discussion and the comments from ordinary people, you will see many comments of a discouraging kind, like this is completely useless, nobody needs algorithms in real life, and the competitive programmers write bad code, and so on. And the main answer to all of this is, has already been given by a very old author called Aesop, who wrote in one of the fables about a fox who is looking at grapes and thinking that she really wants some grapes, she wanted to eat them, but as she jumped and tried to reach them, they were too high, so in the end she concluded, oh, they are too sour, and went away. So all those comments you see in those discussions are precisely these are sour grapes from people who didn't reach the heights you already did. But let's get to the positive side of questions. And the positive side is what to actually do to be better. And the answer is actually simple. You need to see practice for programming competitions as a process, as a game, in terms of like game theory. And what you are supposed to do are the actions that maximize your profit. So you actually need to identify at which phase you are and what is the change, what is the improvement that will bring you the best benefit. As you are starting with programming competitions, this will be things like mastering the tools, actually knowing the language you are using, knowing the libraries, knowing how to use the shell, how to debug efficiently, for instance, knowing how to use Valgrind is a useful thing, and so on. Then you get to a stage where what matters is consistency and code quality, where you will be losing rating in programming competitions, not because you cannot come up with a solution, but because of you make dumb mistakes, your code fails, and then after the contest you realize, oh, here I have less than, should be less than or equal, or some similar stupid mistake, I forgot about 0, I use a 32-bit integer instead of a 64-bit. And this is something where an improvement, a practice, can bring you to a much higher rating very easily. Then we get to things like patterns. If you are implementing your Bradford search for the 3rd time or 4th time in your life, you have to focus, you have to type it. If an experienced contestant does the same thing, they already have the pattern memorized. This is something they did multiple times, they know what they're doing, and while they are typing, they are thinking about the actual rest of the problem, about the actual algorithmic part, and this is where the game. The next thing, contest strategy. In many competitions, your goal is, for instance, to advance to the next round. Many contestants will always use the same strategy. I'm trying to score as many points as I can. This is not always the best strategy. Your best strategy is a strategy that maximizes your probability to advance to the next round. And for instance, it may be better to go slower and to be certain that those tasks you submit and then they are revealed only after the end of the contest, that they are correct, spend some more time testing, and then in the end you will advance. And only after you get all of these obstacles out of your way, then the maximum benefit can directly be gained by learning to be a better problem solver, which is the fun part, which is the part why we are doing what we are doing, why we are taking part in these programming competitions. And again, with the actual problem solving, and I like to make an analogy between like leveling up in competitive programming and role-playing games. If you have an RPG and you make a new character, then the character has many attributes like strength, charisma, and so on. And two of these attributes are really important here as an analogy. One of them is wisdom and the other is intelligence. And sometimes you're asking what is the difference between two. Also in the game is usually something is like one is for a sorcerer, the other is for a wizard. Here we need both of them. The wisdom part is the studying, is seeing the standard algorithms, knowing what has been done, seeing a lot of problems, having a database in your head of solutions, of approaches. And the intelligence, this is the tricky part, this is something where maybe things like talent come into play. This is the part where you have to come up with new clever ideas, to find patterns within those patterns, to find when you approach something completely new, to try to break it apart, to try to come up with a new solution. And both of these things can be improved by practicing. Well, basically everything can be improved by practicing. we the humans are hardwired that way. Since the dawn of evolution, since our personal early childhood, everything we learn by repeating it, by failing at it, and when you try it several times and fail several times, only afterwards we'll actually learn. Alright, I included a picture with some lines now for the talk, and I'm going to talk about mistakes for a little while. When you are practicing for many sports, like for instance you are practicing running, or you are practicing jumping, or you are practicing playing soccer or something like that, there aren't really failures. In the sense you will be a bit faster, you will be a bit slower, but there is no such thing as a complete failure. We sadly know complete failures pretty well. You are given a competition task, you are trying to solve it, and you fail. You get 0 points because you didn't get to the end of the task. And for many people who are doing these programming competitions, these failures can be discouraging. You can read it in every possible forum. There are people saying, oh, I'm dumb, well, I tried solving some problems, I failed, half of them, and then I gave up because this is clearly nothing for me. And this is in my opinion, this is the major misunderstanding people make, and when you are aware of it, it can give you a significant advantage. Mistakes are actually a crucial part of learning, and this I learned when I was doing research in testing theory. So the thing I was researching was the question how to test people, how to test, for instance, how good you are in programming competitions, or how to test kids who are solving competitions in mathematics, or how to test players in golf who are playing on different courses, different holes with different difficulties. And the answer to this has already been given in statistics in form of the so-called item response theory. This is a nice mathematical theory, look it up afterwards. And basically what it says is that for many problems, such as the tasks in a programming contest, what you see are curves like the blue one, or the green one, or the red one. The x-axis represents the skill of the contestant. So the farther right you are, the better the contestant. And the y-axis is the probability that a particular contestant with this skill will successfully solve the problem when given it in a competition. So for all of the tasks we have this like sigmoid characteristic function that somewhere at some skill level has like a 50% probability.